Hello guys and welcome back. What we'll do today would be pretty straightforward. I would like us to look at this topic over here, which has to do with deployment and scaling. And what I would like us today would be just pretty straightforward. So we'll go through the points we have listed here. So we'll talk about building for production, talk about deployment. I would just talk to you a little bit about load balancing and scaling, of course. And then, of course, talk a little bit about monitoring, logging, of course, in production. So let's jump right in. What's the first thing I've already done is if you go over to cargo .toml, I've added just this section that you see over here and just added just three simple attributes. So the first thing you would note, of course, would be like the first very optimization you would need to do for production. The very basic one really would simply to instead of doing something like cargo run, for example, now we can do cargo run release. And of course, apart from this, if we just want to build the binary, I'm probably just going to stop this to show you if you just want to build the binary, and now we can simply say cargo build, and of course we build for release. So that's like the um, first optimization that would need to happen when you're getting ready for production. So the next optimization would have to do, of course, would be this optimization level. So if you look over here, I've had, maybe I also add a comment here. So this will be optimization level. And this can also, maybe also add a comment here, can be S or Z, like we already have here. So the optimization level, what this would do for us would really be to help minimize the binary size that we have in the end after we've built our application. And so that's like one huge benefit we get out of it. But the one point to also note is that this might reduce the runtime speed when this is of course running in production. So that's also one thing to look out for. But one thing we can be guaranteed to get out of this would be like a minimal or a minimized binary size. So of course, like I said, the alternative would be to set the level to S, and which will still, of course, target minimal binary size, but it's a less aggressive, like with the way the minimization is done, in contrast to when we set it to up to level Z. The next important thing, of course, would be the link time optimization, or LTO as you see it here. So this helps more or less to improve the runtime speed, and this from documentation can actually go up from 10 to 20%. So you could get upwards of 10 to 20% of increased or improved runtime speed when you set this flag. Of course, all of this flag actually goes or are more or less considered when your code is being built. So during the build phase, that's also when these configurations are actually considered. So apart from having to set this here in the cargo.toml file, you can of course also have this directly keyed into the terminal if you are running the build, say locally or even say within a Docker, it doesn't really matter. So, but the point is that it doesn't necessarily need to be in here, but of course, it's much more easier to manage if it is in here, but it not necessarily doesn't need to be here. We can also have this keyed in at the terminal when we are running our optimization. And this value can, of course, be completely set to false if you wouldn't want. But other than that, the other options we have would be, I can say it can be thin. Okay, so when this is set to thin, for example, apart from when you can set this to false, is a little more aggressive, when it comes to the improvement of speed and reducing the binary size of your file. And this would be more or less the after above setting this to false, this would more or less be considered as the next level you can actually set this value to if you would want to. So, but other than that, like we already did here, you can also set this to fat, as you can see, and this is a lot more aggressive, and also it tends to offer you much more improvements in performance and reduction of binary size, to further increase build times. So in this our case, which is also what we've done here, we've set this to fed, and the point is that I'm trying to show you like this could be like a much more aggressive way to target improvement of our binary in the end when we are deploying for production. And of course, we have, maybe I also add this here. So I say fed all. So we can also completely shut this off if we want to. So these are some of the options you have when it comes to LTO, but for our use case, I'm just going to stick with fed. And if you look over here, the last thing we've set is code gen units. So normally, when you build your application, what happens is that the compiler basically looks at the, for example, the dependencies that it needs to add into the build. And what it does is actually split those crates into multiple parallel jobs, more or less. So it tries to do the compilation in parallel, of course, to obviously speed up the build phase. But what happens is that with these sets or with these default settings, this might actually cause the compiler to miss some potential optimizations. So if we want to improve our runtime speed and reduce the binary size without, of course, having to have these splits when our crates are actually being, for example, downloaded and maybe built into the final binary, we can set this to 1. And what this would do would be, instead of doing this parallel, all of this would actually be done in a sequential kind of form, but it's of course obviously slower. But the benefits we get out of this is that we can be sure that our code would completely, of course, be optimized without us running into the problem of maybe potentially not missing out some optimizations that could happen to some of those components of our build in the end. So apart from these three I've added here, there are actually a lot more flags we can actually add during this build phase. And as usual, I'm going to leave a link to a documentation so you can also maybe read them up and then see what other flags you could actually add to your application. And then maybe you can again decide for yourself if this would prove useful for your own use case or not. So moving on, maybe I'm just going to close this part so we have more room. So now I'm going to move over to the main file, and I've also added a few more changes in here. And the change I've actually made is basically to, of course, I have updated this import so it doesn't clash with the one we wrote down here. And then what I've actually gone ahead to do is to add this default header. So for cross-site, to prevent more or less against cross-site scripting. And also I added the default compress middleware. So maybe we'll start with this. Why I have this in here is because I really want to more or less be able to protect against like common web vulnerabilities like cross-site scripting and cross-site request forgery. Using this middleware system that already we have offered by Actix. And of course, compression, this is really pretty straightforward. I want to more or less compress the requests um sorry, to compress the responses that we give back to the user. And we can of course extend this to say sharing of files. So we can also use this if, for example, we have a file we would want to share or we generate ourselves, and then we compress this into some form of like you would have, say, for zip, for example. And then what we can simply do is, of course, add the header to the response, and of course we can then ship this response back to the user as in a compressed form. So the benefit would get out of this is that, of course, the file would have a smaller size, and of course, not just the file. Of course, if it's also the response, depending on what we're doing, it will also have a reduced size, and it would take less time, more or less, to be transmitted to the user. So our main function, of course, is already within Actix runtime, and this, of course, gives us efficient and scalable event-driven architecture, more or less, for handling asynchronous operations. So with this, of course, we can leverage async and wait in Tokyo and all that nice stuff that we get from Tokyo from Actix more or less, to leverage handling like a large number of concurrent connections, for example, without the overhead of traditional thread per counter model. So with the Tokyo runtime already embedded into an app, or more or less having an app run within the Tokyo runtime, we can leverage the async and wait that this offers us, and we also can, of course, handle a large number of concurrent connections without the overhead of traditional thread per connection model. The next important thing, of course, would be logging. So we already have this set up, of course, using tracing, including tracing as well. And this is, of course, a really nice approach with what we already did until now. So, but the really, really important thing again we have to handle is, if you look in our application, we have a lot of places where we actually do have lots of unwrap. This is really actually frowned upon. So the important thing I think we have to, of course, first decide would be within our application, what should say we have to be able to classify all the possible errors we could have in our app between um, recoverable and unrecoverable errors. So we have to decide what form of errors we can recover from, and the ones we would completely maybe terminate the program, or maybe terminate the request depending on where the error is actually thrown. So something like, say, if our app depends on the connectivity to a database, for example, and on initialization, let's say in our own case where we are using our app states that we have down up here, I can also go to the definition. So if, of course, our app depends solely on this, say, this Postgres connection pool, and this maybe more or less comprises like the bedrock of what our app does in the end regarding like data and all that. If this is really, really quite crucial, and without it, our app would probably not function, then of course it makes sense that if, for example, when we try to establish a connection to this database, and if it fails, then it doesn't really make any sense to actually overlook this and then still start up the server. It really has no meaning. Otherwise, the app, even though it becomes alive and becomes online, it would probably do nothing, because again, the app depends solely on the data we have to retrieve from the database. So that could be a simple of an unrecoverable error. So if that should happen, it really makes no sense to continue actually serving the application. We should be able to probably panic at this point, and the server should not be able to come online, if you ask me, if we cannot establish a connection to our database. If, again, remember, our app completely depends on it. And also when it pertains to request, for example, if we, let's say, take a look at, say, our the login, for example. So if, for example, this is what we want to handle, like something like this, and we want to establish a connection to, of course, using the pool we already have in our state. If we are not able to acquire this lock to have access to this database connection pool, then these requests would really make no sense going further. Because again, what we give back to the user from this, at least at this point, depends entirely on what we get out from the database using this connection pool, which we unfortunately now do not have access to. So these are some of the things I think we have to really, really pay attention to if we are building for production. Again, I would not use unwrap anywhere at all if I am deploying for production. So you can, of course, decide to handle the errors yourself, or you can also use like third-party libraries, like anyhow. But the important thing is that it's much more reasonable and, of course, easier to maintain if you don't just maybe throw an error when it actually comes up, but rather to be able to propagate this back to the user. So, or more or less back to the person making the request. So if someone has to consume this API, they would really understand what's going on, and not just some meaningless error more or less happening in the back. So that's one thing to really, really look out for. So the next thing I would like us to briefly talk about would be deployment. So that's also, if you look over here, we have this place, but where I would actually like us to deploy to would be to would be to shuttle RS. So maybe I also just add this down here. So shuttle RS. So this is where I would actually deploy to. So what we would do now more or less would be to do some, I think we already did a brief introduction in the past, and that's also okay. We can also do another introduction in this video, but would of course need to start transforming our main function to fit into what it could look like if we would want to deploy to shuttle. So that's what we're going to do now, and then we can of course conclude this section. So moving on to deployment. So like I said, I would like us to deploy this to Shuttle RS. Of course, it doesn't really matter the cloud provider you choose in the end, but you can apply similar approach to say AWS or Azure or GCP, as the case may be. Of course, there are definitely underlying differences as to how you can interact with these providers to deploy your app. But I'm showing you this because this would probably be like the easiest of those other cloud providers as it comes to deploying an application, a backend application, more or less. So with short arrays, this is, I think, purely written in Rust, and they also make it a lot easier to actually deploy applications written in Rust. It's pretty interesting. And as usual, I will leave a link in the description, and I would really encourage you to go check it out. There's so much more, and also make it a lot easier to actually work with them. It's quite easy. And anyways, the app we have right now, we can actually build this, of course, into a Docker image, maybe publish this to a Docker Hub, and then we can use any other service we're already familiar with. Could be simple, say Docker Compose. It could also be say Kubernetes. It could also be like, let's say, within the Azure cloud, you can use like a simple Azure web app for containers. There is so much more you can do. And once you have your app already built as a simple single standalone Docker image. But for this example, like I promised, I would like to deploy this to shuttle arrays. So I would need to do a lot of transformation, more or less, for this to be compatible to shuttle arrays. But of course, to get started, you would need to have cargo, or you would need to, of course, download the shuttle binary, more or less, into your local environment. There are of course really well documented step-by-step guides as to how you can actually get started working with shuttle arrays. But of course, the most important thing would be to have the cargo shuttle already installed locally, and you can of course do this by simply doing a cargo install. You can simply do a cargo install, and then of course cargo shuttle. And you can also, instead of building from source, more or less, you can also do a bin install to simply bin install, not bin install, bin install to simply install a pre-built binary already and to get started. But again, like I said, I'll leave a link. It's really easy to get started. So but I already have this installed, so there is no need for me to actually do this one more time. So, but what I would like to do is just to go ahead now and start making some modifications to the app we have already written so it can be compatible to run within the shuttle environment. Again, the app as is, like I said, can be bundled and built as a Docker image and then pushed to a Docker Hub. But let's make some modifications so we can actually run this within the shuttle environment. And to do that, I've also come over here and added two dependencies. So one is the shuttle Actix Web. So this is actually pre-written in form in such a way that you can actually use this not just with Actix Web, you can also use this with Exum, which is also another interesting web framework in Rust. And I've also added, of course, the shuttle runtime package. So we have all these crates already within here. So what we can just do now is to go ahead and start making modifications. So the first thing I will do is to, instead of Actix Web here, I'm gonna change this to shuttle runtime. So this becomes shuttle runtime .main. I don't think I have this in scope. I would have to import this more or less. Let me see. Okay, anyways, I would like to pass an argument to our main function, and this would be the connection pool to this shared database that I'm using within my account. In the previous video, I already did a short introduction about Shuttle, and I'm also going to leave a link here so you can check it out so we don't waste time repeating what we already did in the past. So, but anyways, I would like to have access to the connectivity to this, of course, shared database. And to do that, I will simply need to provide in here an argument. And the argument I would like to provide here would come from shuttle shared DB. And I can say, of course, Postgres. Um, and then the argument's name would, of course, be pool. And this would be uptype PG pool. This one. And that's really more or less what I would like to provide. And the next thing, of course, I need to change would be the return statement. So in here, instead of simply returning this, now what I would like to return here would actually change. So this would become shuttle Actix Web like this. And now in here, I would like to return a function. It would be, of course, an anonymous function that takes an argument. It's going to take a couple of things as arguments, and one of them would be a mutable reference to service config, and this, of course, can come from service config. You should be able to take a mutable reference to this, and it should, apart from this, it should also, this should also implement the following threads, would will of course include send and clone, and of course static. So this would be the return type of our shuttle main function. And now if you move down here, you can already see we have a lot of errors because this is no longer satisfied. So now what we have to do is simply to move down here and then make the modifications that we also need to see this working. So I can come down in here. So now I'm actually no longer returning this. So I can add a semicolon to get rid of that. And so what I can actually now do is to define a config here. I can say let config. And this, I'm gonna, again, because of the signature of what we need to return, so I have to more or less provide here an anonymous function. So it's gonna take a config arguments, sorry, CFG, I would like that to be called. And this config arguments, again, like we defined, should be a mutable reference to a web, a service config object. And now, of course, we need to define what this body should look like. So, but already what I can actually do here um, is to return this. So I can simply say an OK. And in here, I'm going to simply pass config and I say that into. And that should already take care of our return statements. But now we also, of course, need to take care of in here because nothing is actually being specified right now within our config. So I can simply come in here and say config and say dot service. Now within here, we again, just like we've been doing before, I would need to provide a service factory. And what I would like to do here, actually, the step I would probably want to do here, take here would be to maybe prepend all our APIs, more or less version them. So we can actually maybe go ahead and just hard code a version up here, or we can also have this defined as an argument. Doesn't really matter. But so what I can simply do here is I define a scope. I can say web.scope, and now I provide a scope. So I'm just going to version this. I'm just going to call this v1 for now. And what I can simply do is to maybe come up here, copy all of this, come down here and dump all of them. And now what I can also do is to maybe get rid of these parts. And now that we have this, now I can actually maybe comment this out for now. And what did I do? I can, yes, I can comment all of this out for now. We don't need this anymore. And now we have a problem with this data right here because we seem to have already moved it in the past. I'm just going to quickly check. So now this is what our app should look like. Sorry, we're now actually ready to deploy our app to Shuttle. So one thing I can actually do maybe is to leave a comment here, and I can say uncomment this part out if you would like to run outside of Shuttle. And of course, you would also need these parts maybe, and not these parts if you would only like to, maybe I remove this comment in here. So you would probably only just need this part if you like to build this, say, into a Docker image that you can maybe now run in your own defined environment or custom environment. Doesn't really matter. So, and maybe what I can also do is to tell you a little bit about this argument we have here. So with this, what can happen, of course, within the shuttle environment is that this would give us access to more or less working with the shared database and that we have available to us. And now with this, of course, we can do all we've actually done. So if I come over here, for example, where we have this argument here, where we actually we are running this where is it, this part where we actually executing this query, more or less, that actually helps us to say create our database initially, because if you come back in here, what we actually passing here is just an argument as a file. So instead of doing this now, we can actually just go ahead and use this directly in here, because now I can actually do exactly what you have up there. I can say pull that execute, and you can exactly also do what we have in here. So that's really one nice thing. Again, this gives you access to this database that you have access to within the shuttle environment. So more or less, we have actually transformed our app right now, and it's actually ready to be run within the shuttle environment. So to test this locally, what you can simply do would be to now do something like can simply do cargo, and we can say shuttle, cargo shuttle run, and then this should now run our application locally. That's actually all you have to do. But again, to run this, you would need to have Docker pre-installed locally, because again, shuttle depends on Docker to be able to, of course, spin up the required images that it needs to run this locally. But of course, within the environment, it's configured to take care of itself, so you don't have to worry about that when it's deployed. And so that's all we actually need to do to deploy our app. I can just move over to, maybe I bring this over here. So again, move over to shuttle.rs, and I can quickly show you if you have the time. So I already have an account created and a couple of projects running in there, and I can quickly also show you how to get started. So if you look over here, I'm right now logged into Shuttle, and I have just one project. And if you see here, it's also said it's ready. So I have access to this app here. I can actually look into the logs to see actually what's going on. And yeah, you also see what resources you have available to you. So if you look over here, I have access to this Postgres database. And of course, there is there are a couple of other services that Shuttle provides, and one of them would be secrets. So you also have the option to store like secrets, say your connection to database. You can actually store those as secrets, and then actually have your app reference those secrets during runtime. So there's a lot more you can actually do in here. But anyways, that's all I wanted to do you under this topic. So regarding the topic of if we go over to our app, we can come back in here and go to README. So if we come over here, we talked a little bit of what I need to talk about, load balancing and scaling. So unfortunately, this would not be something we can actually just do in this tutorial, especially when we are considering deploying our app into a third-party cloud provider, for example, like Shuttle. Mostly this is what would be handled, or more or less would be given the option to handle this, of course, within that environment. But more or less this can mostly not be something we can like code into our application. So but this is why I have this here, because I think this is really important that I mention this to you. So it's really important to pay attention to load balancing and scaling topics, because in production, it's you would not always be there, for example, to monitor how your app runs, to monitor the amount of load coming into your app, to monitor the amount of resources being used, the amount of resources left behind, and maybe to actually tell when your app is running out of resources. So this is actually where load balancing and scaling comes in, and they are mostly, of course, should always be used hand in hand. So with scaling, you also have the option to either say scale horizontally or vertically. So you have the option to actually add a lot more resources to this single instance you have running, or you can actually add multiple instances. And then when you have multiple instances, that's when load balancing come in. You now want to distribute the incoming load to these different instances you already have, just so that you don't have one instance doing all the work and the other ones idling away. And it's also important to consider auto scaling topics, so that you don't end up paying for resources you need, or also you don't want to always be there to sit around to decide when you want to scale up or down. So with auto scaling, you can automatically scale up when there is lots load and lots traffic to your API, and of course, we would like to scale down when this load also goes away. So again, this is really a vast topic, and of course, it's handled differently within any different cloud provider, but in the end, the underlying concept remains the same. So I really wanted to call your attention to that. Anyway, guys, that's all I wanted to show you in this series. The next time would really just move ahead to these advanced topics. We've already talking about middlewares and filters, but maybe we can also shed a little bit more light on them. But other than that, we can just go ahead and talk about caching, and maybe talk again in detail a little bit about asynchronous programming with Tokyo. And of course, we'll also show you web assembly as well. Anyways, guys, that will be all for this topic for today. And yeah, that's where we draw the curtain. Yeah, guys, if you are new to the channel, of course, go ahead and subscribe, and we always promise to bring you interesting topics. That's we always profuseful that you can always learn from. Anyway, guys, that will be all for now. Until we see each other again, stay learning and have a lovely evening. Bye bye.